Thanks to those of you that's come along to listen to what we do at Datarock. Today I'm going to be telling you a little bit about what we do at Datarock at a high level, and also demonstrating some of the workflow in the software as well. So to start with, a little bit about us. We're really a mining technology company. We're based in Australia. We have two main functions within the business. So we have an applied science team, which is a consulting group that really focus on applying data science to mining and exploration. And then we have a processing platform, which I'll be demonstrating today, which is all about extracting value from the humble core photograph and other imagery types. So yeah, that's us. So the question we commonly get is, what can you extract from a core photograph? So what kinds of data sets can you actually get? So on the geotechnical side, the things that we really commonly produce, things like RQD, fracture frequency, we can measure fracture orientation, we measure curvature and angularity of fractures. We produce joint set numbers and produce weathering models. So they're the really key things that we make on a regular basis from core photography. And on the geological side, it's much more bespoke. So we create lots of different model types, some of which are shown on the screen here. But it's really about what you can see in the images. So if you can see a feature of interest, we can build a model to extract that data and map it across the deposit. So that's really the broad scale of what can be done. And the key thing is you must be able to see the thing that we need to map in the photograph. That's really the basic foundation that limits the technology. So how can you engage with Datarock? So we process historical data. And so for us, it's all about getting all of your historical data unified with models, and then getting you set up in the core shed. So every time a core tray is produced and taken to the core shed, it gets imaged, and then it can be uploaded to Datarock, processed. The geologist can log into the platform and interact with that data. And then once everyone's happy with what's been produced, it can then flow onto the database via APIs. So we call this our near live logging workflow. How quickly the data is produced is really a function of the core shed and the order in which data is created. But typically for us, a 500-meter drill hole will take around 30 minutes to process in the platform. Okay, so moving into a quick demonstration here. Okay, great. So here I've logged into the platform and I've arrived at what we call our project page. Project page is where all the drill holes belonging to a particular deposit or a particular project can live. Every drill hole is a line here in the table. And what you'll see here is we have a series of these icons showing up next to each drill hole. These tell us what products have been run against each of those drill holes. So here we have IP, which stands for image preparation. It's the cropping of those raw core photographs. DR stands for depth registration. It's where we take those depth registered strips and we arrange them in depth space, and using a process I'll explain in a moment. DB is the detection of drills' break marks. We produce RQD, fracture frequency, fracture segmentation, joint set analysis, a geotech weathering intensity model, and a lithology model. So I'll show you a selection of these in the demonstration. So the first question is, how does data arrive in the platform? So we have APIs that can drag data automatically from commonly used software and any kind of cloud repository. Data that we need in terms of ancillary data can be pulled via API from commonly used database solutions like Acquire. Once the data's in, we can basically select the holes we'd like to run, click on the actions menu, and essentially just hit a button, and that's basically it. And as I mentioned, around 30 minutes for a 500-meter drill hole. So let's go through the workflow in some more detail for a particular drill hole. So as I mentioned, the first step we have here is the cropping of the boxes. So we take that original core box photo, which could have lots of information around it we don't care about. We also crop the rows of the rock out automatically. These red marks you see here are an automatically applied cropping mark. We also have the ability to add metadata at this stage, so where the box starts and ends, and along with the box number. At this stage, we can also upload ancillary data, so we can upload sample files that allow us to match data onto intervals that have been created in the core shed. And we also accept core loss files, which allow us to register the depth strip imagery with as much detail and accuracy as possible. Okay, so moving on to the next step, which is our depth registration workflow. So here you can see that we have the data in this kind of neat strip imagery view. We have the ability to zoom right in on the imagery into a lot of detail. We can jump around to different depths. And you'll notice here that we have these green marks on the imagery here. These are our digital meter marks. We create these by reading the numbers directly off the core tray. So 293, we've actually read the number 293 straight off the rock. And that allows us to put a pierce point of depth in and can allow for the most accurate depth registration possible. But we also detect everything that's going on inside the row of the core tray. So we detect every piece of rock, we measure every piece of rock, and we use that and the information we can read to produce a regression for depth, which is really accurate. As part of that process, we can also do what we call a depth health check, and that allows us to actually work out whether we've measured too much rock or not enough rock based on the data we've been supplied by the client. And this is a really important piece of QA/QC that commonly isn't done on core photography. Here you can see that we've detected that there's too much rock in this core tray. We've even told you how much there is. And that's because this start depth is actually a meter out. So we've picked up a human error on a core tray. And with historical core photography, there's commonly lots of these QA/QC issues that aren't addressed in the mining chain. Okay, so moving on to the actual data, the things that are the most interesting. So here, what we can see is we have the same kind of view that we had before, but on the side here, we've got all of the different visual detections that have been applied to that image based on whatever we've processed against the data. So we start off with the non-geological things. So non-geological things are things like where there's empty tray, where there's driller's brake marks, where there are core blocks. So we can go and see some detections of core blocks, empty spaces, etc. If we want to look at a data set like ArcUD, we can turn on all of the masks related to that ArcUD product. And that allows us to go and actually analyse the detections, make sure we don't see anything wrong, and really just QA/QC the data and make sure that we're happy with it. That's all well and good, but what we really want to look at are the numbers we're creating. So you can click on the charts tab here and we can look at a full drill hole of ArcUD. This ArcUD can also be calculated on the customer's intervals and compared against log data. So here in red, we've got data logged by the geologist on site, and the green is the data we've created just from the core photos alone. So quality-wise, we're aiming for basically as good as an engineer, and we're trying to do that in a very short space of time on a very large amount of data. Okay, so moving on to other data types. So we also detect lots of fractures. We can produce the commonly produced geotechnical fracture frequency and spacing. We detect a box around every type of break. We have multiple classes of fractures that we can detect. And that all feeds into what we call fracture frequency and spacing model. Again, here we can calculate on the user-defined intervals and produce that as interval table CSV data for the client to use. Moving on to something a bit more of a geological application, we can look at things like lithology. So let's turn that on. So here what we can notice is that we've got what we call just a lithology model. And what we're doing here is we're actually detecting what kind of rock we've found at every point of the image, and we give it a class, very similar to what a geologist does when they're logging core. You can see here that we're actually logging this core at very high detail, so around 5 centimetres in this particular case. And that allows us to create very high resolution data that can then be composited and upscaled for the client's use. Okay, let me zoom out and just show you the scale of this. So in this particular drill hole, we might have something like 10 to 20,000 individual detections. And so we were able to log at a very high resolution compared to a geologist. Okay, so that's probably all I wanted to go through here. Was there any questions for the end of the demo, or anyone? See, our colleagues over here might have a couple. Cool. Otherwise, I might turn it over to the next speaker. Thanks very much for listening.